I'm Kate Nelson, the Director of Sustainability, as Carly mentioned. I've been at the U for about 15 months now here in this role, and I stepped right into the climate action planning for the Twin Cities campus. As some of you might know, we completed on the emissions mitigation side a whole plan and many strategies that are already underway in implementation, but we also worked on assessing our vulnerabilities and our strengths as it comes to climate change now and in the next about 50 years. And so we really broke that down into understanding when we're talking about infrastructure and energy systems, what are we talking about and what are the vulnerabilities there, as well as with our environment, defining that and understanding it. And then our campus community as well that is also affected by these climate hazards. Something that comes through really strong in this type of planning that is different than most planning is that we're not just talking about the shocks of climate change. We're not just talking about the floods or the days over 100. We're talking also about the stress of climate change. Sometimes the things we don't see very much, how our campus community and our staff handle high heat days, multiple days in a row. How our trees and our habitat is also responding, not only to those high heat days, but also warmer winters and so forth. And so we are just about complete with the plan. It's in actual final design, and we'll be going to the Board of Regents in June for discussion. So it's been a very important topic for our campus, for our office in particular, and my work as I have started here. It's really important work, and it shouldn't be overlooked when we are thinking about the decarbonization being so prime and central, but really thinking about how this is affecting us every day. And it's a pleasure to have our guests today to be able to delve into this a little bit deeper. There's so much expertise on this campus and around us that we are bursting to share more of that. So Carly, I'll let you take it away with that.
Wonderful. Thanks, Kate. So today we have three panelists from very different areas of the university. First, we have Dr. Stefan Lees. He is a researcher in the Department of Soil, Water, and Climate. We have Elliot Redman, who is a land care supervisor. So he is working, on the ground with these types of environmental assets and things that Kate was mentioning. And then Kate Gerber, who is a CFANS undergraduate student and works with us in the Office of Sustainability, and has worked very closely with the Climate Action Plan and both the Climate Resilience Plan. So we will go ahead and allow each of these panelists to give kind of an introduction to themselves and their work. We're going to try to keep each one of these kind of introductory presentations, I would say, under 10 minutes per speaker, so we have enough time to get to everyone and also leave enough time at the end for some questions and discussion. I'm fine with just going in this order if our panelists are. Dr. Lees, and please correct me if I'm pronouncing your last name wrong. Are you willing to
No,
kick
that
us
was
off?
perfect. Thank you. Yeah, thanks, Carly. So I'm already at the U since 2008 as a climate researcher. And as you said, I'm working at the Department for Soil, Water, and Climate. But I'm also affiliated with the Minnesota Climate Adaptation Partnership, where we look more at the regional scale, because my background is actually global climate pattern, and these interactions. But now more recently, I work with the Climate Adaptation Partnership on the regional scale here over Minnesota, where we look at really individual counties and the projections of the climate. And I did a previous study with older climate models that has been published, and the data are out there on the university's library website. It's called DRUM, like Data Repository of the University of Minnesota, I think it's what it means. And so those projections are available for everybody to download and look into the data. And now more recently, I'm updating them with a newer product, and we have a website of that one. And maybe I can share my screen with some slides. I'm just being quick about it, hopefully. So this is our main website from the Climate Adaptation Partnership. And I hope you see it in the same way as I do. Otherwise, sometimes you see the speaker view. But anyway, just being quick. Here's the website address, climate.umn.edu, and we have multiple projects. And again, I'm more in the climate side of the projecting, and then others will do the work afterwards to identify which risks are posed by these climate data that I'm producing. And so I'm really just looking at here in this case, all of the state of Minnesota, the average. This is like a typical year. On the top left, what we see now, like we have colder winters, warmer summers, of course, and winters can be pretty cold in the historical. And now that's the top left panel. The other three are just the future projections, where we just look at anomalies. With a straight line at 0 is the current temperature, and then we see increases, as Kate mentioned, especially the warmer winters are prevalent in Minnesota, and we get warmer summers too, though. And this is kind of typically being expected. But now what I found interesting also, that we see changes in rainfall also, that we actually, here again, seeing top left is what the models usually produce, and the gray line is the observations. So the models that I'm using are actually a little bit drier than what we was hoping to produce. But what we do now, then we just look at anomalies. And this is what you see at IPCC reports also, that people don't tell you the temperature or the precipitation of the planet, because honestly, nobody knows that. Nobody has measurements everywhere. We just look at anomalies from past to future. And looking at those anomalies we see here in this moderate scenario, we see a lot of noise in there. These time series don't really tell you much. But when we look at the more extreme scenarios, we see that actually here in the bottom right especially, we see that all these models produce a wetter spring. So winter and spring is usually wetter. So this winter was more like an exception because of El Nino being dry, but warmer is being still expected. But now from June to July, we see this very sharp decrease in precipitation anomalies. So we see that March, April, May get wetter, and then July, August, September getting actually quite dry. And usually people in spring feel like, oh, great, like yesterday, today we get wetter climate. That means it's better for the environment, for the plants. They need the moisture. But unfortunately, what I don't show here is that when we look at these hourly and 3-hourly data, we see actually that the way the precipitation comes down is different from what we had in the past. So we see these more torrential rainfalls and then longer dry spells in between, which is unfortunately also not that good for the environment. And these data are also now available for looking at and then downloading. We have this website here. I only have the website here, this app.climate.umn.edu. Sorry, I should have taken a screenshot also. This just gives you a rough idea on how climate over Minnesota is going to look like. And people can click on different temperature, precipitation, and snowfall values, and length of heat waves, and so forth. And again, these are all simulated results. So we have a large range of results. But yeah, this is something that might be hopefully interesting to folks. And yeah, I think I'm going to stop there to leave more space for the others also. Thanks.
Thanks so much, Dr. Lees. And if you have questions, let's hold those till the end of our 3 panelists. So just keep them up here, jot them down if you need to. I know I will probably have some questions for Dr. Lees. Let's move on to Elliot Redmond from Landcare.
Great, thanks, Carly. Hi, everybody. My name is Elliot Redmond. I'm a grounds supervisor at the U of M here at Landcare. We're responsible for Twin Cities campus only. One of my responsibilities is to manage our tree program and the crew of field arborists. So I've worked at the university for 11 years now. I've really grown to appreciate working on the same trees every year, working on the same sites, because it gives a pretty good indication of how things change and how they can respond to different things that are happening. So in the next 10 minutes or so, I'll just try to give you a bit of a background about our campus tree inventory, sort of the reality of how we replace trees, the canopy cover, and then how some of that ties into the tree resilience. So I'm gonna share my screen here. I don't have slides, but just try to show a few different visuals. Get my bearings. Okay. Is everyone looking at a map here? Great, thanks. And then I was going to put some of these links in the chat. I can't find the chat with, that's okay. I'll just look at these here. So what we're looking at here is the pre-GIS that we use daily to manage our campus trees. And so each of these points is a tree. And then we also have these different polygons for wooded spaces that are on campus. So this is a public map that anyone can access. So for example, if we scroll into the hall that they named after me, Elliott Hall, click on one of these points. This is one of my favorite trees on campus here, but you can see the different things that we collect about any given tree. So everything has an indicator or number, talks about the genus, species, etc. So we use this sort of information to day-to-day operations and decision making on how we're doing different treatments to our trees. Throughout campus, we have roughly 10,000 trees. It ebbs and flows a little bit, of course, but it's just kind of a nice, easy round number. So 10,000 trees on campus, and then about 15 of these urban woodlands. And so those are kind of across all parts of campus as well. A lot of tree pests attack trees at the genus level. And so a lot of what we talk about is kind of different measurables at the genus level. And so this document here is our tree management plan, which the Office of Sustainability helped us to create recently, just completed in December. This is on our land care website as well. You can find a link to that there. But what I want to just point out a few things here. We have 59 different genera on campus. And again, that number kind of goes up and down as we plant different types of trees and things either are successful or not. But what we try to do is, one of our goals is striving to have every genus that does not exceed 5% of the total tree population. So what I'm highlighting here in this tree plan, we only have 6 different genus on campus that do currently exceed that 5% threshold. So maples, honey locusts, spruce, pine, oaks, and linden are those 6 that exceed that. And so that's just one thing that we're working towards and have been working towards for quite some time as a way to diversify the canopy that we have on campus. And that's based on different things in the industry. There's sort of different rules or rules of thumb, I should say, that municipalities will strive for. But again, since a lot of pests attack at the genus level, like emerald ash borer, Dutch elm disease, those things, we're trying, rather than diversify the species level, we're trying to diversify at that genus level. Since the year 2000, so talking now a little bit about how we replace trees on campus. Inevitably, trees die. We plant new trees all the time. And so just to give you a kind of a little insight into that, again, this is a visual just from our tree management plan. And what it's showing is since the year 2000, the green lines are trees that we've planted in that year, and the red lines are trees that we've removed in that year. So, things have changed quite a bit in the last couple decades. You see that big spike of removals around 2006 to 2012. A lot of that was due to emerald ash borer. And so overall, if we take a look at this last 20 or so years, we have actually a deficit of about 120 trees annually that we are, if you compare trees that we're planting compared to trees that we are removing. And so, that's not the direction we want to be going, but it's important for us to recognize where that's at and understand what's contributed to those numbers and how we can kind of take steps towards more positive numbers. But one thing that's really important to me is emphasizing the quality of trees more so than the quantity. It's important to keep and protect the trees that we can and protect the ones that we have. A large tree offers a lot more benefits than 10 small trees. And so, we're constantly challenged with construction or different projects and trying to protect trees. And so that's one really important aspect of what we do. We've put a big emphasis on young tree maintenance. You know, when we do plant trees, we want to make sure that they live. We don't want to just plant trees to pad our stats, so to speak, and, you know, make the green lines on this bar really high. That doesn't really do a whole lot if we can't maintain those trees and if they're not thriving for years to come. So I say that we really are only trying to plant the number of trees that we can maintain. You know, that could be based on our funding or our labor resources or any number of things. And then the other thing that I'd like to point out, a lot of people are familiar with emerald ash borer, and so just to a kind of snapshot of where we're at on how that's affected us on campus. So these two really simple bar graphs are just showing the population of ash trees on this left-hand side from the year 2008. So ash used to be about 12% of our canopy. So it's a very prevalent genus that we had on campus. And that totaled about 1,500 trees. Now, currently we're sitting at 135 trees, which is about or less than 1% of our total tree population. So any ash trees that are still on campus are being treated at this point. So that's, you know, just kind of where things are at there. And as we replace trees, you know, of course, there's a lot of consideration to the adaptability that a tree may have, its climate vulnerability. Is it hardy? Will it be hardy in the future? Can it sustain higher heat zone? And so we're always trying to plant things that are a little bit out of the box or out of the comfort zone. And we've had varied success on that. But we certainly have been trying those things for a number of years now. But ultimately, a lot of it comes down to the availability of what they have in the nurseries and where we can find trees. So that's been another challenge. And then just to talk about our canopy cover a bit, that's another area that people, you know, it's kind of a hot topic. Well, what's your canopy cover? You know, what percent canopy cover do you have? You know, that's another one of those, I think, it's an easy, tangible thing that people grab onto and they can, you know, say, oh, that's really impressive or not. Well, you know, if I told you all to guess what's our canopy cover, you could probably be thinking about a very wide range of numbers. But to me, it's not so much about what's that number, you know, how are you measuring that? What's your process? And so to explain a bit more how we measure that here on campus, you know, we are using this map here. This is what we call our land care areas map. This really just kind of, these blobs just show the boundaries of our maintenance crews. But overall, all of these boundaries show more or less the territory that we maintain. And so if you notice, it's not all of university property. You know, Murphy Warehouse is excluded, the golf course is excluded, the ag experiment stations are excluded. We don't maintain those areas. So when we talk about our canopy cover, I'm not talking about all of campus property, I'm really just talking about the areas that land care is responsible for maintaining. That's where we have our control. And if we're going to try to influence that canopy cover number, this is really the only areas that we can do that with. So I know you're all dying to know, but currently we're sitting at roughly 7% canopy cover. To me, it feels a little underwhelming. You know, we went through a really long process to try to determine what that is. We're using the total square footage from this land care area map, and then we're also using real DBH measurements or diameter at breast height measurements of all of our trees, and then using a projection or a multiplier to project what that diameter is of each tree. I can give you a little visual of what that looks like. So we use GIS to do this, but what we're looking at here is the knoll area of campus. So this would be a current image of what our projected canopy cover looks like in the knoll area. So I'm a visual person. I thought maybe people would appreciate seeing that. Here's another example. This is over by the football stadium. You know, you can kind of see some of these green dots. You know, these are all really small trees right now. They have a small diameter. They have a small canopy. So what we've also done is gone through this exercise of projecting out what will the canopy be, assuming that all these trees continue to live, you know, in the next 50 years. And they grow at the same rate that they have been growing. You know, again, we have some of these unique kind of multipliers that we've got mixed in there. But so if you keep your eye on the map here, and then here's 50 years in the future, the same area. So it's not perfect, but it's a tool that, you know, can help kind of illustrate where things are at and how that plays into planning for the future. We want to touch on tree resilience, and just want to draw people's attention to this document here. Maybe when I stop sharing my screen, I could share this link, but this is recent research that Landcare contributed our GIS data to, and it talked about urban forest biodiversity and climate vulnerability across the 7 metro area. And so it lists out the most common trees that each of the everyone who contributed data, it takes the trees in their inventory and assesses them based on their urban adaptability, their hardiness, their heat zone suitability, and then ultimately tells us how vulnerable are those particular trees to the climate change that we're experiencing. So it's really helpful for a practitioner like me or people in other municipalities, because it lists out all these common species, and it tells us with these real clear symbols that, hey, this one's really high adaptability, this one is zone suitable, this one has a low vulnerability. And so you can kind of hand select these different species and try to incorporate them into your planting plans, which we are doing. I can say that I've looked through this whole sheet, and to pull out anything that is all 3 of those have the most favorable responses in the adaptability and vulnerability, et cetera. And about a quarter of our canopy is within those trees. On the flip side, if I picked out all of the least favorable criteria, less than 0.1% of our trees are falling in that category, and they're all tulip poplars, which we are planting because they're great. But so we're on the right track, but there's obviously 75% or so of our trees are within the middle somewhere, and so trying to determine a bit more of how, just how we're using this tool and where we're going from there. So that's kind of the gist of what I wanted to share here. But yeah, most people I think understand that trees are good and have a lot of benefits, of course, and planting trees is definitely good. But again, I think we just need to be resistant to the padding our stats, just planting trees to plant trees. It's not a set it and forget it. You have to make sure that there's enough resources in place to maintain them and keep your population thriving. So I really appreciate everyone's time, and I'll stop sharing here.
Thanks, Elliot. We had a quick question in the chat. Does Landcare maintain the grounds around the Masonic Institute for the Developing Brain down the river a bit?
Yes. Yep. Just Landcare also.
Another question for you, Elliot. We'll just get to these really, really quickly. Sure. Amy is wondering, do you give tours or way for folks to do a self-guided tour?
I don't personally give tours typically, but there are, we're working with the forestry group. We have a tree advisory committee, and I've worked with this different forestry classes the past few years about developing a campus arboretum. And there are a lot of interest in trees, and people want to know, what type of tree is this? Or, what if I wanted to see a particular species, how would I even go and find it? So that's what that group is trying to make more accessible and easier to find.
Wonderful. Well, thanks so much, Elliot. And I just wanted to mention, we're talking about tours. Our office does have a self-guided tour on our website. I can get that link for you at some point and throw that in the chat. It's just more of a general campus sustainability tour. With that, Elliot, we're going to say something.
I was just going to say, I'm just going to chat the links that I had here, because I couldn't do it as I was sharing my screen. So I don't mean to interrupt the next speaker, but I'll just share these quick.
No, please do. With that, I'm going to turn it over to our final speaker, Kate Gerber. Kate, do you want to take it away?
Yes, hello everyone. I'm going to go ahead and share my screen. I have some slides. So I'm going to be talking a little bit more about resilience and adaptation at the U oh my gosh, that is the wrong button. As I am our intern right now for it. Like Carly said earlier, I have worked since March of 2023 with this, and before that I worked with our mitigation side of the CAP. So a little bit more about me. I am from Chicago-ish. I'm currently a sophomore here at the U. I'm an environmental science policy and management major, and I've been working with the Office of Sustainability since October 2022. I worked with the U Fleet for our climate action plan, and then transitioned last year to work with the resilience plan. A little picture of me in Duluth. I'm from Chicago, so I love to explore new places in Minnesota. Super fun. So just a little bit more about the resilience plan in general. I know we touched on it a little earlier, but we're actually going to go back in time to the first climate action plan. There's our lovely cover by Hannah, our office communications person. This plan has been presented and approved to the Board of Regents as of May 2023. That's super exciting. As again was said earlier, it has certain goals and strategies that we're going to be hitting now and through the next 10-ish years. And for that, we had 5 groups of energy, supply and demand, U-Fleet, travel, commuting, and it also laid the groundwork for what I'm talking about today, which is our resilience plan. It's currently being implemented university-wide, and there's this cool little progress chart that you can check out. Yesterday I was asking my roommates what they wanted to hear from this, and they wanted to have a tangible way to see what progress we were making, and I said, great news. We have that up and going, and we will update this as our resilience plan is pushed through the university as well. So just a little bit about our methodology for how we decided what we wanted to focus on for our resilience plan. We had a working group with a bunch of different faculty and staff from around the university, and they ranked them based on their unique working experience. So we had a list of assets that the working group then ranked and said, well, we should focus on this because this is the most vulnerable, yada, yada, yada. And that brings us to this. So I'm really breezing through. I will be getting to the environment. So these are all of the assets that we specifically focused on as we started to craft this resilience plan, specifically within the environment. We wanted to focus on tree canopy, so great following the land care trees. And then we also are going to be focusing on green space around campus. So that's going to be areas, first thing that I think of is the knoll or the mall, because that's where I like to hang out as a student. And then also the riverbanks. So what the university owns is along the river. Those were the 3 most important assets that we wanted to focus on and make resilient. And that doesn't mean that we ruled out everything else. This is just what we thought was most timely for today. So within these 3 assets, here's a quick blurb on why we wanted to do all of them. Tree canopy is important, as we just learned. They provide shade, but also host a host of ecosystem services around campus. Climate change is affecting everything around us, including the trees. And I don't want to repeat too much of what Elliot said, but just we want to make sure that the trees that we have on campus are being cared for, that we can try to have more resilient trees on campus, that we're not going to be hitting that deficit. Just everybody likes the trees. They're kind of fun to see around. And then as we move on into green space, like I said earlier, anecdotally, students love green space, especially with this amazing weather this last weekend. Everybody was out on campus. It's one of the most visible spots on campus for the environment. And then on a more scientific side, the green space around campus supports important biodiversity. So in addition to the knoll and the mall, we also have a lot of ecosystem places like pollinator gardens. There's a new building being built on St. Paul that's the side of facing the street. If you ever take the bus over there, they're going to make that a little ecosystem area. There's prairies on St. Paul, the sheep's pasture. There's just a whole host of important biodiversity that's supported by the green space. And we wanted to focus on that in the resilience plan because, like I said earlier, it's a pretty public-facing place. And it's also just important to maintain the biodiversity of Minnesota, as we do have a pretty big urban footprint. We want to try and preserve everything we can within the university. And then going to the riverbank, we all know the Mississippi River. It's literally the heart of the community. And we're in such a unique position that we're situated on top of it. And I mean, it's running straight through campus. We're the only bluffs in the entire Mississippi River. So we're just in a really cool spot. And because of that, we want to be resilient in terms of what the bluffs are doing, the erosion factors. We've had a lot of meetings about those. So just ensuring that everything is not going to be too upset by climate change, but we know it's coming, we know it's here. So what can we do to proactively prepare campus to be resilient to these changes? What trees can we plant to make sure that they're going to be resilient? What plants can we plant in the green spaces to provide a space for the changing climate and for the changing migration patterns, all of that. So then just from a more student perspective, this plan has been really great, and we really wanted to get all of the campus community involved, including students. So this has come through engagement with student groups from probably November through the start of January. We just had a lot of focus groups. We wanted to make sure that we were speaking with every group possible on campus, students, faculty, staff groups, the works, to make sure that everybody knew what was going on and that we had their input on how they thought resilience should look. Through this, we also had town halls and hosted campus-wide engagement. This is a picture from one of our town halls. This was our final one, where we had a class of students come in. We had some of our working group members come in and people that have been involved throughout the process to really just make sure that everybody knew what we were doing for resilience on campus. And we also just want to make information accessible. It can be kind of easy to get lost in the amount of information that this university generates and all the plans that are going on. So we have a super cool website that has, like I showed earlier, our progress dashboard, but also the climate action plan, what we're up to, and all of that. And so then just in general, again, I asked my roommates yesterday, I said, what do you guys want to know about this? And they really just wanted to know the impact that the resilience plan was going to have on them. They wanted to know if it was going to raise tuition, which you're not going to start seeing probably like a $100 surcharge. So it's not going to impact you like that, but it's going to impact you in the fact that your campus is now resilient. It's going to be able to withstand the changing climate of Minnesota, and it's going to be able to be, we'll just keep saying the word resilient, it's going to be able to withstand and be more resilient to anything that is going to be out of the ordinary. We did a lot of precipitation models and how that's going to change. So the rain gardens are going to be fun. The smart ponds that we're going to put in that are going to be able to predict the changing water levels from the precipitation would be a good way to go after resilience. And just in general, we wanted to make sure that the students, to the best that we could do before it was published, that they had the input on what we wanted to do. We met with Carly's class and we talked to them about what they wanted. So just in general, we wanted to make sure that since this is going to have a, hopefully, and it will be, positive impact on the students and staff and the faculty, they will all know how it impacts them as a community. We've already seen progress with, the climate action plan mitigation side and how that's been beneficial. We've already seen how that is making an impact on the community, and it's rather forward-facing again in some aspects. We want to make sure that this is also being forward-facing and transparent throughout the entire process. And that is all I have.
Thank you so much, Kate. That was great. So we have three very different but equally important perspectives on this issue of climate resilience and how it's going to affect the environment and specifically our campus environment. We have about 20 or so minutes left. So now we'd like to open it up to questions. You don't have to raise your hand. You can just go ahead and unmute and speak or throw a question in the chat if you would rather do that. So I will open the floor up to questions.
I've got a
I do have
question.
one
Might
actually.
be
Oh,
easier
go ahead.
just to ask it out loud. So this, I was noticing in the data that you were talking about tree coverage, planting, removal, and that type of thing, that there have only been a handful of years since 2001 where the university has been able to plant more trees than it's removed. And so I'm just wondering if there's, if it's possible to turn that statistic around where the U is able to plant at least the equal number of trees that it's removing annually, if there's some type of like policy around that, or just curious.
Yeah, thanks, Cassidy. Good question. We've worked toward, or kind of tossed around different ideas about like a policy, or how to handle that more formally. And I don't want to like enforce or impose a policy on ourselves that we may or may not be able to uphold. But I can say that there's a lot of influences that go into the planting, and why it's difficult to kind of keep up with what's happening on campus. The emerald ash borer was one easy example. There's other pests and course of things that you can't plan for, that trees that need to be removed. There's a lot of capital projects that happen across campus that have implications on trees and the surrounding landscape. And while there's often trees that are planted during capital projects, this is where I said kind of the quality over quantity can be more important sometimes, because a project may wipe out a large tree and then plant a couple more trees in its place, but that's not always the case. And then, during COVID, we're still seeing implications from that, where, we had to be pretty selective with some of the tasks that we would continue doing, and we would specifically not continue doing during that time. Planting was one of them, that it wasn't a, health safety thing for that short period of time. So we specifically did not plant trees, but we did remove trees, so those are kind of just a couple, easy examples. But I'm with you. I share your concern of wanting to get trending in that better direction here. And, we have some ideas to try to make that happen, but it's just difficult to gain traction and make that a reality sometimes.
Thank you.
I was just having a quick follow-up on the tree species. You mentioned you wanted to go for bigger diversity. And I barely know that there's something on the carbon sink of a tree. The different tree species have different abilities to store carbon. And I'm wondering if there's any information out there, or if you have any ideas on if that goes into decision-making of which tree to plant.
Yeah, great question. I haven't seen any research on that specifically. I'd be really interested to learn more. In terms of storing carbon, I think where we've thought more about that is, again, from a construction standpoint, removing large trees, removing a lot bigger capacity to store carbon. So removing a large tree and planting 10 small trees, it's not a one-for-one solution. So I guess what I could say, the work that we're doing is really trying to protect the large trees that we do have, in particular from construction impacts.
Yeah, thanks.
Jump in to help both these questions. So we were setting objectives for the climate resilience plan based around those assets that Kate shared. And actually, the first strategy is based on what is the right objective for tree canopy. And it's asking ourselves, what is the purpose of tree canopy? First of all, it's the trees themselves and the human health factor that there's so much about, like Kate just really mentioned, like the students, they talked a lot about the need for natural spaces inside and outside, just the comfort level. But then, so the first strategy is, what is the right amount for carbon sequestration, for stormwater management, biodiversity, things like that, habitat. So we are asking ourselves, before setting a target, what is our goal? Is our goal all of those? Is it one of those? So Elliot, I know I've got quite a bit of follow-up with you and Tom, but that was actually how we approached it. We didn't think it was just a number. We thought a lot more about what purpose trees serve in our environment, and the trees themselves. The trees have value, intrinsic, even before they suit our needs sometimes. So There's a lot that will go into that. And that's actually our first strategy in under that topic area. So carbon sequestration, we do need to better understand the carbon sequestration of these trees.
Just to pile on to that topic, because I think it's very good, and I'm fascinated with the idea that we take down more trees than we plant. And I think if we follow those goals that Kate just talked about, it would seem that the cost of removing a tree includes the cost of replacement. I don't know how you budget for that, because it's, you know, it turns into money right at the end. Isn't that the way it is? It's all about the budget.
Yeah, for sure. And, you know, in a lot of those cases, if they are capital projects, that restoration cost is built in. Sometimes it's not, you know, the landscaping can, I'm a little bit removed from that process because it's sort of a different program in land care, but I'm brought into it kind of in more of an advisory role of, hey, you know, what trees should we plant here, et cetera. But sometimes the landscaping can be an add-on, you know, to a project. And so it's not always built right into it, unfortunately. We're kind of handed the aftermath of a project, but sometimes it is built right into it.
Kate, do you know, do we have landscaping requirements in our buildings benchmarks and beyond criteria in the sustainability 2030?
Yeah, I'm still learning and understanding that system because it's so unique to Minnesota. So I'm not sure. But there's other strategies that tap into that and understanding the balance between hardscape. You know, we're not going to suddenly add trees also to our agricultural fields, you know, so tree canopy just has these sort of definitions already built into it where we can and cannot put trees. So looking at it more holistically, and that was really, I want to say, like, doing this work with the people who understand, and the data we had on the environment, the data and information we had on infrastructure really played into each other quite well, because we had to really understand, how does tree pollen affect our building filters? And, you know, then it's your energy efficiency. I even heard about, like, when there's more buildings and trees, there's more shade, and we actually have more slips, trips, and falls in the winter from the shade and so forth. So there was so much to take in, and there were so many voices sharing the information at the same time, that throughout and then the campus community, which we're going to hear more about on Monday, but essentially like stringing these things together to get the best of it all, and really striking that balance here with the stormwater infrastructure, what it does for us in terms of heavy rain events. And I know, Dr. Elise, you talked about, like, rainfall is changing. I've been really interested in that with St. Anthony Falls lab. And essentially, what's the trees capacity and what's the gray infrastructure capacity, using future climate models to understand this. And Jay, our current codes tend, I think, almost 100% look at historical data. So that's a big change in how we do planting, how we do buildings, is getting the future climate information into our codes and design. And that's also part of our strategies as well. So I wish I could speak more to that, but we will need to better understand what already exists to know what we need to do further. And that kind of just shows up in different points along the plan. Very excited when it'll be ready in June to share out.
Yeah, maybe to quickly follow up on that, as you said, like, these trees have a lot of benefits, and especially in the future climate, we see, like, usually I show, like, yeah, we have warming and then weather climate, but it's becoming more intricate that, as I mentioned earlier, the weather climate can lead still to longer dry spells because rain comes down, torrential falls, and with temperatures the same thing. The average might go up, but we still see the cold spells coming in. So the general rule is more like, with global warming, we put more energy into the system, so we steer it around more, and therefore we get more variability. So the cold spells might not go away, but we see longer warm periods in between. Oh, and then, yeah, the follow-up is then we need then to have trees that actually can handle all these variabilities. So it's good to have diversity, but we need to find then those species that can handle all this. And some trees that we have now might not survive in 50 years or so.
I have a question on Stefan's slides at the beginning. You had those 4 graphs that one was showing a historical and then 3 projected future instances. My question is, all those lines were bouncing up and down. What did each color line represent? Were they just different modeling, or what were those different colors?
Yeah, let me show you this one here again. This was the most bouncy one, I think. Yeah, so here we only have 6 models, like these long acronyms. I don't know if you can see my mouse here on the legend. It starts with BCC and so forth. These are all model, like GCMs. These are general circulation models that project global climate. And the bottom one is this prism. These are the observations in gray. So I don't unfortunately have the average of all the models. I only show the variability here, because in global climate, we usually like to look at the average, but then in regional climate, we sometimes do this cherry picking where we first look like which model is actually closest to the observations in the past. And then we just assume that a model that was doing well in the past would do well in the future also. But here in the graphs, I only show you the variability of all these 6 models that we used here. And again, like the gray line, it would be the observations, which is just the 0 line and the anomalies. And so we have then these 6 models. They come from international centers, like BCC is from China, CESM2 is from the US, CMCC is from Italy, and CNRM is from France, and so forth. So these global models, they exist on a repository, and we take those data and we use one, like a weather forecast model, and run this weather forecast model. Instead of for 10 days, we run it for 20 years and then project then the climate over Minnesota on a very much smaller scale. This is like a 3 mile by 3 mile grid box, and that the model calculates, and it has then therefore like 200 by 200 grid boxes about over Minnesota. And so this is much finer than the global model. A global model might just have 1 box over 100 by 100 mile area. Oh yeah, and then as I mentioned, it's a weather forecast model, and usually, as we know from forecast, it's really accurate for up to like 5 to 10 days, and then it just crashes because it's really trying to project these 10 days. And we have a different goal in climate models. The difference there is that we need to make sure our model stays stable over 20 years. So we do some damping tricks. So especially when we look at water, for example, a weather forecast model would give you the exact, like making sure that it gets the rainfall right at the right hour or so. But in our case, we just want to show that we have a roughly weather that exists for 20 years, like the variability of the weather, the day-to-day variability should be somewhere there, although we don't have exact days. What we do have then, what I mentioned with water, for example, a bucket in the model that says when the model gets too dry, because after 10 days, the weather forecast model might just go berserk, kind of, as you know from computer programs, sometimes they just crash when they get into a realm where they're not reliable anymore. So we do this damping where we say, don't do this, don't crash, stay normal, stay normal. So staying normal means then it stays in a reasonable range, but it doesn't have an exact value there from day to day that we can't tell you this is the weather going to be on 17th of July 2084. Instead, we just tell you this is a possibility for that day. I hope that answers the question somehow.
It does. Say, I have a follow-up question. The different models certainly show trends, which I think is valuable, but I'm still looking at this graph and trying to understand it. You have 0 on the historical one at the bottom, but then you have 0 in the middle on the other 3 with negative numbers. How do you interpret that?
Oh yeah, I should have given you more details on this, that the top left one is the actual value. So we don't have rainfall below 0. So this is just and on the x-axis, you see the months from January to December. So the top left one just gives you, the gray line is the observed rainfall over a typical period, 1995 to 2014. So we average over all those years and just give you a monthly value there, one value for January, one for February, and so forth. And we see June is the wettest month in Minnesota. And then all the colorful lines are then the models trying to represent that. And we see the BCC, the CMCC, the green line is closest to the observations here in getting highest in May, June. And the other ones show like they actually simulate a climate that's slightly drier than what we observe. And that's where I earlier mentioned that we take those models and we know our historical models are wrong. Every computer model does not represent reality. There's always a mistake in there. So what we look at then is the trends, and these are the other three graphs. That's why we have 0 now in the middle, because we just say this gray line that we saw here in the first graph, we just look at the anomalies here. We don't look at this graph as starting at 0, but we say 0 is, like for example, in July, the actual value is 0.15 here, but we just say 0.15 is 0. How do the models behave relative to this gray line? So all the other three are anomalies. That means it's just the relative value compared to the observations being present to us, and now we look at what do the models simulate for the future. Do they simulate the exact same value as the historical value? Then they would all line up on the 0 line. As soon as they deviate from that, we just show the deviation and we say some models are wetter, some are drier. And in the far future, we see that most of them are wetter in May, June, and most of them are drier in July, August. Yeah, but please interrupt me and let me know if there's anything unclear, because these graphs can be sometimes quite difficult to interpret. Yeah, so maybe it's easiest to say that the 0 line is there because the models showed the deviation from normal. And so normal is just treated as 0 then.
Thank you.
Got just a few moments left. Any additional questions for any of our three speakers?
I have a question for Kate. So, you talk about students, really having certain desires or appreciating the green spaces or the trees. Do you think that students know where to provide feedback or know how to give input about things that are important to them?
Fantastic question. And it came up, I think, for us a little bit more with indoor spaces, actually. It's amazing the corners of campus students will find, but oddly, another comment that struck me, and I say this because it came out of different groups, was just knowing where to go and find a good place to study that was comfortable as well. Somehow that comment came out a lot as well. And I didn't know what to do with that information, honestly. I mean, I should talk to our planning group and so forth, but I don't think that they do. Kate, maybe you wanna, maybe you meant this for other Kate. We call ourselves Kate Squared.
Kate Squared. I mean, yes and no. I think most students know about like the little pin map. There's a lot of different study rooms that have pins, and then there's a map online. But in terms of giving feedback, I don't even think I would know where to go off the top of my head. And like other Kate was saying, it is just like a lot of random spots that people will go to study. Empty classrooms are a big one. And the rooms that they do have reserved for studying get snatched up so fast, especially during, I mean, this busy season. So I think it is a struggle for students, and they don't have anywhere to put their thoughts or feedback for that, or at least know of anywhere to put their thoughts or feedback.
Yeah, it was almost like once we showed up with some understanding of our environment, our built environment and so forth, we just got a flood of, like, students just had something to say.
Mhm.
And they don't often get approached like that in small groups where they can share their thoughts on the space on campus. I think that's what really came out.
All right. Well, it is now just about 10 a.m. And I wanted to just share my screen one more time to let you guys know what we have coming up. So first off, thank you so much to our 3 panelists today for taking the time out of their busy schedules to speak with us about climate resilience and how it's impacting our campus. And thank you to all of our participants for being here, sharing your morning with us. Hopefully you have some takeaway from this hour. We do have one final event coming up in this climate resilience series for Earth Month, coming up on Monday the 22nd on Earth Day, very fitting, from 9:30 to 10:30, again on Zoom. And this one will be on climate resilience in our campus community. I think this is going to be a really interesting one, very focused on things like public health and how a changing climate is really impacting us as humans and our health and our well-being. I think this will be an awesome way to finish up this series. So I hope that you will join us for that one, and we will continue on with our sustainability coffee chat series after Earth Month as well. So thank you guys so much. If you have any questions, you can always reach out to our office, and we hope to see you soon.